The Swedish embassy in Ukraine just confirmed a massive transfer. 26 additional Archer systems have been handed over to the Ukrainian armed forces, likely part of Sweden's 20th military aid package. This isn't just a top-up, it's a game changer. We aren't just talking about a specialized experimental squad of 8 anymore. Ukraine is building a full-scale Archer fleet, but this sudden influx of hardware makes the critical questions in this video even more urgent. With the fleet tripling in size, the logistics and maintenance challenge just got 3 times harder. So let's find out if this spaceship is actually ready to handle the workload. For the last 30 years, Western military doctrine has been built on a seductive promise. The promise was that technology would replace mass. We were told that one smart bomb is worth 1,000 dumb shells. We were told that comfort keeps crews alive, that computers eliminate human error, and that the future of war looks like a clean, precise laboratory. We were wrong. When the Russians crossed the border in 2022, they didn't bring a laboratory. They brought a meat grinder. They brought mud that swallows tanks whole. And into this hellscape, NATO poured its most advanced, expensive, and complex machines, the fully automated, climate-controlled digital marvels designed to fight a theoretical war that no longer exists. But after 4 years of the most brutal combat in modern history, we have to ask the uncomfortable question: did we over-engineer ourselves into a corner? Is a multi-million-dollar robot actually better than a rusted iron cannon that just works? Today, we are stripping away the marketing hype to rigorously analyze the 2 most advanced artillery systems on the planet, the German PZH-2000 and the Swedish Archer. We are going to find out if superior technology is actually the answer, or if it is a trap. Hit like and subscribe to support the channel. Thanks. We are used to the heavy hitters of the free world coming from the usual suspects. When we talk about raw firepower, we look to the industrial might of the United States. When we talk about precision engineering, we look to Germany. When we talk about sheer volume, we look to the legacy of the Soviet Union. But there is one weapon system currently operating in the Donbass that defies all the stereotypes. It comes from a nation that hasn't fought a war in over 200 years. A nation we associate with flat-pack furniture, safety-conscious family cars, and aggressive neutrality. Sweden. We are talking about the Archer. If you look at the glossy brochures, this isn't just a howitzer. It is a spaceship on wheels. It is the fastest, most automated, most futuristic artillery system on the face of the Earth. It was promised to be the sniper of artillery, a machine so advanced it would make the American Paladin look like a musket from the Civil War. But war has a way of taking beautiful theories and dragging them through the mud, literally. Because right now, in the forests of eastern Ukraine, the best artillery system in the world is facing a crisis that no one talked about in the press releases. It is a crisis of fragility. A crisis where a simple engine failure turns a multi-million-dollar robot into a useless brick. We are going to look at how 8 Swedish Archers went to war, how they stopped a tank assault that should have been impossible to stop, and why, shockingly, only a fraction of them are actually able to fight today. Is the Archer the future of warfare? Or is it a technological dead end that can't handle the grit of a real fight? Let's find out. To understand the Archer, you have to understand the paranoia of the Cold War. For decades, Sweden sat in a terrifying geographical position. They were neutral, yes, but they were also the speed bump between the Soviet Union and the North Atlantic. They knew that if the Red Army ever decided to move, they would come with thousands of tanks, waves of infantry, and a storm of artillery that would black out the sun. Sweden has a small population. They could not trade lives for lives. They couldn't build a trench line and hold it with massed infantry. Their doctrine was built on one word: movement. They needed to hit the enemy, bleed them, and vanish before the Soviet counter-battery radar could even lock onto their position. They needed a weapon that didn't require a battalion of men to operate. The project began in 1995. It moved at what we might call a Swedish pace: methodical, slow, obsessive. It took nearly 20 years of tinkering to get it right. By 2023, Sweden had 48 of these machines. Half were in service. The other half were sitting in cold storage, gathering dust, waiting for a political deal to send them to Norway that never happened. But history has a sense of irony. Instead of guarding the fjords of Scandinavia, 8 of these sleeping giants were woken up and sent to the most intense artillery duel on the planet, Ukraine. When the Archer finally arrived in Ukraine's 45th and 43rd Artillery Brigades, the crews didn't know what to make of it. They were used to the Soviet Tu-S7 Pion, a 203mm monster that looks like a locomotive and hits like a sledgehammer. The Pion is brute force. It is loud, dirty, and manual. The Archer? The Archer is an alien. Let's look at why the world fell in love with this machine. First, the speed. In modern artillery warfare, time is life. When you fire a 155mm shell, modern counter-battery radar detects the projectile in flight, calculates the trajectory, and pinpoints your location before your shell even hits the ground. You have, at best, 2 minutes before return fire rains down on your head. The Archer laughs at 2 minutes. Imagine a 30-ton armored truck tearing down a highway at 70 kilometers per hour. It slams on the brakes. In 30 seconds, the stabilizers deploy, the gun elevates, and it is ready to fire. Bang, bang, bang. It fires 3 rounds in roughly 12 seconds. And here is the magic trick. Before those 3 rounds even impact the target, the Archer is already folding up its gun. Within 30 seconds of the last shot, it is back on the road, moving away. It is a phantom. By the time the Russian counter-battery fire hits the coordinates, the Archer is a mile away, and the crew is listening to Spotify in the air-conditioned cab. Second, the automation. In a standard American Paladin, the inside of the turret is a sweatbox. Men are heaving 40-kilogram shells, shoving propellant charges, shouting over the noise. It is physical, exhausting labor. In the Archer, the crew of 3, driver, commander, and operator, sit in the armored cabin. They never touch the ammo. They never smell the propellant. It is more like playing a video game than fighting a war. The crew never has to leave the armored cabin. The shells are pre-loaded into a magazine, just like bullets in a rifle. This allows for the Archer's party piece, multiple round simultaneous impact. The computer is so smart that it can fire 4 shells at 4 different trajectories. The first one is fired high, into the stratosphere. The second, a bit lower. The third, lower still. The fourth, almost flat. The computer calculates the flight time so that all 4 shells land on the Russian bunker at the exact same millisecond. For the Russian soldiers on the receiving end, there is no warning. No initial explosion to make them take cover. Just instant, total annihilation. This capability makes the Archer a surgical tool. It isn't a sledgehammer like the Pion. It is a sniper rifle with a 50-kilometer range. The Ukrainian crews call it the Crocodile because of its long, green, snout-like barrel resting over the cab. And they absolutely love the comfort. The 43rd Artillery Brigade took these machines and integrated them into a new kind of warfare. They don't operate in batteries of 6 guns lined up in a field. That is suicide in the age of drones. They operate as lone wolves. They drive with an escort car carrying electronic warfare jammers and a guy with a shotgun to hunt drones. They sneak into position, they strike, they vanish. We have footage of the crews. They have named their guns after their Swedish instructors, Matilda, Alice, Hugo, Ulf. It's a touching tribute. In a way, they are fighting alongside us, one soldier said. Matilda destroys the occupiers, and the combat record is terrifyingly impressive. There is a story from the Battle of Kursk. The Russians tried to break the line with a massive armored fist. 18 tanks, a nightmare scenario for light infantry. 3 Archers were in the sector, just 3. They synchronized their fire. They used the MRSI capability. They turned the lead tanks into burning wrecks, blocking the road. Then they dismantled the rest. Jurist, a former judge who used to fight corruption in courtrooms and now fights tanks in mud, described the feeling with a level of adrenaline that you can't fake. You say in the radio, Matilda, fire. Amanda, fire. Hugo, fire. It's better than sex, really. It's longer, and much better. He pauses, realizes what he said, and adds, "Don't show my wife. Cut it." This is the peak of the Archer's reputation. Fast, lethal, a tank killer. a machine that makes its crew feel invincible. But every hero has a tragic flaw, and the Archer's flaw is hidden deep inside its engineering.
Here's our Archer, totally frozen up. We're in the middle of this damn field waiting for an enemy Lancet. Here are the anti-aircraft guys. One of my buddies is scanning for the Lancet in the air.
After months of high-intensity combat, a disturbing statistic emerged from the Ukrainian General Staff: 34%. That was the readiness rate of the Archer fleet at one point. Out of 8 units delivered, only 2 or 3 were actually combat capable at any given time. The rest were in the repair shop. Why? It wasn't the gun. The cannon itself is a masterpiece of metallurgy. It wasn't the computer software. It was the truck. The Archer is built on a Volvo A30D articulated hauler chassis. Essentially, it is a modified mining dump truck. On paper, this is brilliant. It means you have excellent off-road capability, and you can buy spare tires at a civilian heavy machinery dealer. But a mining truck is designed to haul dirt, dump it, and go back for more. It is not designed to carry a massive, vibrating, recoiling artillery system through deep mud 24 hours a day, while being hunted by drones. The problem is the integration. In a traditional tracked howitzer like the Paladin or the German PZH-2000, the engine drives the tracks, and a separate auxiliary power unit, APU, or hydraulic system runs the turret. There is redundancy. In the Archer, the chassis engine is the heart of everything. The Volvo engine powers the hydraulics that lift the gun. It powers the generator that runs the targeting computer. It powers the autoloader. Here is the simple, brutal logic of the Archer's failure. If the engine dies, the weapon dies. If the chassis breaks an axle in the mud, and the Ukrainian mud is notorious for snapping axles, the Archer is not just immobile. It is a paperweight. You cannot hand crank the autoloader. You cannot manually traverse the turret efficiently, and the chassis is breaking. The complexity of the system is its undoing. The sensors that allow for that 30-second deployment are delicate. They don't like constant vibration. They don't like dust. They don't like the damp, freezing Ukrainian winter. It's a tricky system. Compare this to the Bodana, the Ukrainian-made truck-mounted howitzer. The Bodana is a sledgehammer. It's a gun bolted to a Tatra truck. It's manual, it's crude, it doesn't have an autoloader. But if the truck breaks down, you can still fire the gun. If the electronics fail, you can use optical sights and hand cranks. The Archer offers no such forgiveness. It is an all-or-nothing machine. When it works, it is the god of war. When a sensor fails or the Volvo engine coughs, it is a 30-ton target waiting to be destroyed. This fragility creates a massive burden on the human element. Training to operate an Archer is not like learning to drive a car. It's like learning to fly a jet. The Ukrainian crew spent 2 months in Sweden with 0 days off. Wake up at 6 a.m. training all day, one soldier recalled. What they taught us in a month and a half normally takes 6 to 10 months. This means the crews are elite. They are highly skilled professionals, but there are very few of them. If one crew member gets sick or wounded or transferred, the efficiency of the unit drops. You cannot just grab a guy from a mortar team and throw him into the Archer's commander's seat. He wouldn't know which button starts the firing sequence and which one reboots the ballistic computer. And then there is the maintenance. There are only 8 Archers in Ukraine, with more promised but slow to arrive. This is a zoo of logistics. You need specific Volvo parts. You need Swedish electronics technicians. You need specialized lubricants. When you have 200 systems, like the M109 Paladin, you can cannibalize one to fix another. When you have 8, every loss is a catastrophe. This scarcity forces the commanders to be conservative. They can't risk the Archers on high-risk missions as often as they would like. They are firing less, not just because of ammo shortages, which are critical across the entire front, but because they have to preserve the barrel life and the chassis mechanics. There's plenty of work for Archer, the commander says. But in terms of firing, we're running low. We're prioritizing only the most important targets now. They are hunting high-value assets, counter battery, enemy command posts. They are not wasting Swedish precision steel on a lone infantryman in a trench. So, as we stand here today, 4 years into a war that has consumed the stockpiles of the entire Western world, where does the Archer stand? It is a paradox. In terms of pure performance, ballistics, speed, accuracy, it is likely the best wheeled howitzer in existence. The capability to fire 4 rounds and have them land simultaneously is a game changer. The safety of the crew in that armored cabin is second to none. The stories from the Battle of Kursk prove that in the hands of a skilled crew, 3 Archers can do the work of a whole battalion. But the 34% readiness rate is a warning siren. It teaches us that in a long, grinding, dirty war, reliability is a weapon. A gun that shoots 90% as well, but works 99% of the time is often better than a gun that shoots 100% perfectly, but spends half its life in the garage. The Archer is a Formula One car rallying on a dirt track. It is magnificent, but it is fragile. The reliance on the chassis engine for all combat functions is a design choice that makes sense for peacetime Sweden, defending good roads near maintenance hubs. In the mud of Donbas, miles from support, it is a liability. The Ukrainians love them. They treat them like royalty. They name them like family members. But they also hold their breath every time they turn the key, hoping the Volvo engine roars to life one more time. As we look to the future, the US Army is eyeing the Archer to replace its aging M109 ES. They see the automation, they see the speed, but they should look closely at the mud of Ukraine. The Archer has proven that wheeled artillery can dominate, but it has also proven that you cannot engineer your way out of the basic realities of mechanical wear and tear. That is the trade-off of modern warfare, the balance between the silver bullet and the iron sledgehammer. For 20 years, this machine was the undisputed king of artillery. On paper, the German PZH 2000 is a technological marvel, fully automated, armored like a tank, and comfortable enough to operate in slippers. But military history is full of marvels that failed the moment they hit real mud. Critics said it was too complex, too heavy, a diva that would break down in a war of attrition. So did German over-engineering fail in Ukraine, or did it redefine what artillery can do? Today, we separate the marketing brochure from the brutal reality. This is the ultimate review of the PZH 2000. When military analysts discuss self-propelled artillery, the conversation almost invariably gravitates towards one machine, the Panzerhaubitze 2000. Often described as the Rolls-Royce of howitzers or a studio apartment on tracks, this German-made behemoth represents the pinnacle of Cold War engineering, tailored for a high-intensity conflict in Europe. But for decades, its reputation was built largely on firing range tests and low-intensity peacekeeping missions in arid climates like Afghanistan. It was a theoretical champion that changed dramatically with the Russian invasion of Ukraine. For the first time, the PZH 2000 was thrown into the environment it was designed for, the muddy, freezing, and artillery-saturated battlefields of Eastern Europe. It faced a peer adversary capable of massive counter-battery fire, electronic warfare, and drone swarms. This review seeks to answer a fundamental question. Does the complexity of German engineering hold up when the war demands not just precision, but brutal endurance? By analyzing operational data, maintenance logs, and tactical shifts observed over years of combat in Ukraine, we can finally separate the marketing brochure from the battlefield reality. We will dissect its firepower, mobility, protection, and the logistical nightmares that come with operating the most advanced artillery system in the world. And before we dive deep into the topic, please support the channel by subscribing. It allows us to grow. Thank you. To understand the PZH 2000, one must first understand its scale. Weighing in at nearly 57 tons, with add-on armor, it is heavier than many main battle tanks, including early T-70s. This mass is not accidental. It is the result of a specific design philosophy that prioritizes crew survivability and sustained operations above all else. Inside, the vehicle contrasts sharply with its Soviet counterparts like the Tu S-7 Pion or the Tu S-19 Emsta S. While Soviet doctrine viewed the crew as replaceable components of the machine, German engineers designed the PZH 2000 with long-duration missions in mind. The interior is pressurized, climate-controlled, and spacious enough to allow the crew to stand upright. This is not merely a luxury. In a chemical, biological, or nuclear NBC environment, or simply during the freezing Ukrainian winter, this environment reduces fatigue. A less fatigued crew makes fewer calculation errors, fires faster, and stays combat effective longer. The layout accommodates a standard crew of 5: commander, driver, gunner, and 2 loaders. However, the high degree of automation means the system can theoretically be operated by just 3 people, or even 2 in extreme emergency scenarios. This redundancy is a critical feature in a war of attrition, where personnel shortages are a constant reality. The heart of the PZH-2000 is its 155mm L52 chromium-lined barrel, developed by Rheinmetall. But the gun is only as good as the system feeding it. The PZH-2000 utilizes a fully automated shell loading system with a pneumatic flick rammer. This mechanism manages the 60-round magazine located in the center of the chassis. In artillery duels, speed is life. The PZH-2000 claims a burst rate of 3 rounds in roughly 9 seconds and up to 10 rounds in nearly 1 minute. Operational experience in Ukraine has confirmed these metrics are achievable, provided the system is well maintained. This rapid-fire capability allows for the execution of the multiple-round simultaneous impact tactic. MRSI is the artillery equivalent of a time-on-target strike performed by a single gun. By altering the elevation of the barrel and the propellant charge for each shot, the PZH-2000 can launch up to 5 shells on different trajectories that all arrive at the target at the exact same instant. For Russian infantry or light armor in the open, this is devastating. There is no warning whistle of the first shell to prompt them to take cover. The entire barrage lands simultaneously. Unlike the shells, the propellant charges, modular charges, are loaded manually by the 2 loaders. This hybrid approach allows the crew to quickly adjust the range by adding or removing charge modules. However, it also introduces a human variable into the rate of fire, particularly during prolonged engagements where physical exhaustion sets in. The transition from Soviet-era systems to the PZH-2000 was a culture shock for Ukrainian crews, moving from manual optical sights and analog calculation circles to the PZH-2000's MICMOS digital fire control computer was compared to upgrading from a vintage sedan to a starship. The onboard ballistics computer handles every variable: wind speed, air temperature, propellant temperature, barrel wear, and even the Earth's rotation. This automation allows for a lay and fire capability that is unmatched. The PZH-2000 does not need to deploy outriggers or spades to stabilize itself before firing. It can stop, receive coordinates via data link, fire a burst, and move again in under 2 minutes. This capability is the cornerstone of shoot and scoot tactics. In a battlefield environment teeming with counter-battery radars, like the Russian Zoo Park one, and loitering munitions, staying static is a death sentence. The PZH-2000's ability to be miles away from its firing position before its shells even hit the target has been the primary factor in its relatively low loss rates, compared to towed artillery like the M777. However, this high-tech approach has a downside. The system is intolerant of abuse. Delicate sensors and miles of wiring are susceptible to the damp, muddy conditions of the Donbass. Error codes became a common headache for crews used to fixing equipment with a sledgehammer and a wrench. The learning curve for maintenance personnel was steep, requiring specialized laptops and diagnostic software rather than brute force mechanics. One of the most surprising revelations from the Ukrainian front has been the PZH-2000's resilience against modern threats, particularly drones, while many Western and Soviet vehicles are now routinely fitted with slat armor, cope cages, and anti-drone screens. The PZH-2000 often operates without them. Why? The answer lies in its structural engineering. The turret is covered with hedgehog armor, rubber thorns designed to scatter the jet of shaped charge warheads from cluster munitions. The propellant charges, which is the most volatile part of the ammo load, are stored in the rear of the turret, separated from the crew by a high-strength blast door. In the event of a penetration, blowout panels on the roof vent the explosion upwards, saving the crew and often the vehicle itself. This design philosophy stands in stark contrast to Russian autoloader systems, like the T-72 or Tu-S-19, where the crew sits directly on top of the ammunition. There are documented cases in Ukraine where PZH-2000s took direct hits from Lancets. And not only did the crew survive, but the vehicle remained mobile enough to retreat for repairs. The effectiveness of the PZH-2000 is multiplied by the advanced ammunition it fires. High explosive rounds offer a respectable range of 30 kilometers. Ukraine has utilized the full spectrum of NATO 155mm advancements. Perhaps the most lethal round in the arsenal is the German DM702, known as SM-ART-155. This is a sensor-fused munition. Once fired over a target area, the shell releases 2 sub-munitions on parachutes. These sub-munitions spin, scanning the ground with infrared and radar sensors. Upon detecting a tank or armored vehicle, they fire an explosively formed penetrator, EFP, through the thin top armor of the target. Operational reports indicate that a single PZH-2000 firing SMART 155s can halt an entire armored column in minutes without ever having a direct line of sight. This capability forces Russian armor to disperse and hide, breaking the momentum of assaults. For high-value targets like command posts or electronic warfare stations, the GPS-guided M982 Excalibur offers surgical precision up to 40 to 50 kilometers. While Russian electronic warfare, jamming, has reduced the efficiency of GPS-guided rounds over time, they remain a potent tool. The Italian-German Volcano rounds extend this range even further, potentially up to 70 to 80 kilometers, allowing the PZH-2000 to strike deep into the Russian rear, rivaling the reach of HYMARS rockets, but at a fraction of the cost per shot. It is not all praise, however. The war in Ukraine has exposed the PZH-2000's Achilles heel, its maintenance intensity. The system was designed for the Cold War doctrine of fight furiously for a few days, then rest. It was not designed for the artillery barrages like in the Battle of Bakhmut or Avdiivka, where a single gun might fire 300 to 500 rounds in 24 hours. This intensity leads to rapid barrel wear and overheating of the autoloader mechanism. The error message culture of the German computer system meant that initially, the gun would refuse to fire if sensors detected parameters slightly outside of optimal norms. Ukrainian crews, out of necessity, learned to bypass some of these safety locks or reboot the system mid-battle. Furthermore, the PZH-2000 is a logistical heavyweight. It requires high-quality fuel, specific lubricants, and cleaner propellant charges than older systems. Repairing significant damage often requires shipping the massive 57-ton vehicle all the way to specialized workshops in Lithuania or Germany, removing it from the battlefield for weeks or months. This logistical tale is the primary argument critics use when comparing it to simpler systems like the French Caesar or the Czech Dana. The chassis of the PZH-2000 shares components with the Leopard 1 and Leopard 2 tanks, powered by a massive MTU-881K, a 500 diesel engine, producing nearly 1,000 horsepower. On paper, it is agile. In reality, its weight is a limiting factor. In the Ukrainian mud season, 57 tons is a liability. While tracked vehicles generally fare better than wheeled ones, like the Caesar or Bodana, the PZH-2000 can still bog down. Recovery requires heavy armored recovery vehicles like the Bergapanzer III. Additionally, many rural bridges in eastern Ukraine are not rated for such weight, restricting the tactical mobility of the system and forcing commanders to plan routes carefully. However, when the ground is solid, the PZH-2000 is surprisingly fast, capable of road speeds up to 60 kilometers per hour. This speed is vital for the scoot part of its survival strategy. Before 2022, the combat record of the PZH-2000 was limited to ISAF operations in Afghanistan. Dutch and German crews used them effectively against Taliban positions. But the nature of that conflict was vastly different. It was asymmetric warfare. The PZH-2000S acted as sniper rifles, firing a few rounds a day from static, heavily fortified bases, FOBs. They were never under threat of counter-battery fire or drone strikes. The lessons learned in Afghanistan, mostly related to air conditioning and dust filters, were insufficient for Ukraine. The high-intensity usage mode, considered a theoretical emergency scenario in NATO manuals, became the daily routine in Donbass. The fact that the system did not catastrophically fail under this pressure is a testament to the over-engineering typical of the German defense industry. An interesting footnote in the history of the PZH-2000, relevant to understanding its raw power, is the Monarch project. In the early 2000s, the German Navy attempted to mount the PZH-2000 turret onto a frigate, the Hamburg. The idea was to replace naval guns with a system capable of firing standard, cheaper army ammunition at naval targets. While the recoil dampening system worked and the gun could fire from the deck, the project was ultimately scrapped. The corrosion from salt water and the complexity of integrating army software with naval radar proved too costly. However, this experiment highlights the sheer versatility and modularity of the turret design. It is a self-contained weapon system that was literally too powerful for the ships of that era. To truly evaluate the PZH-2000, we must place it alongside its peers in Ukraine. The KRAB uses a chassis licensed from South Korea, K9 Thunder, and a British turret design. It is simpler, slightly more rugged, and easier to repair. The KRAB is the workhorse, while the PZH is the precision instrument. The Caesar is a truck-mounted gun. It wins on strategic mobility and ease of maintenance, but offers zero protection for the crew and lacks the 360-degree turret traverse and tracked mobility required for mud. The Paladin is the veteran. It is reliable and numerous, but significantly outranged by the PZH-2000 L39 barrel versus L52 barrel, and fires much slower due to lack of full automation. The PZH-2000 has proven itself to be the undisputed heavyweight champion of self-propelled artillery in the Russo-Ukrainian War. It combines the firepower of a battery into a single vehicle, offers tank-level protection to its crew, and delivers precision that fundamentally changes the geometry of the battlefield. However, it is not a wonder weapon in the sense that it is invincible or maintenance-free. It is a high-maintenance diva that demands a professional logistical chain and highly trained crews. When treated correctly, kept clean and dry, as the manuals say, it dominates. When neglected or pushed beyond its limits without care, it becomes a 57-ton paperweight. Ultimately, the PZH-2000 has validated the Western doctrine of quality over quantity. One German howitzer, integrating with drones and firing smart munitions, has shown it can achieve tactical results that would require an entire battery of Soviet-era guns, all while keeping its crew alive to fight another day. In the brutal calculus of war, that survivability is its greatest asset. So, what have we learned from the German fortress and the Swedish spaceship? Both of these systems are marvels. They are undeniably superior to the Soviet-era metal they replaced. They save lives. They destroy targets with a precision that 20th century commanders could only dream of. But they also reveal a dangerous flaw in Western military thinking. We fell in love with the idea of the wonder weapon. We spent decades designing systems for a war where we would have total air superiority, perfect logistics, and short, sharp battles. We designed systems for comfort and efficiency, but we forgot about resilience. The PZH-2000 is a diva that needs a clean workshop to keep firing. The Archer is a glass cannon that needs an elite pit crew to keep moving. But war is not a workshop. War is mud and blood and chaos. In 1945, the T-34 tank defeated the German Tiger not because it was better, but because it was simpler, reliable, and there were thousands of them. Today, Ukraine is teaching us that while it is nice to have a touchscreen fire control system and a climate-controlled cabin, the most important feature of a weapon is simply availability. A perfect Archer that is sitting in a repair shop with a broken axle is infinitely less useful than an obsolete M109 Paladin or a crude Bodana that is out on the line firing shells right now. The future of war isn't just about high-tech sensors. It's about building machines that can be fixed with a hammer, fueled with dirty diesel, and operated by a soldier with 2 weeks of training. Because when the high-tech sensors fail, and they always fail, you are left with just the metal. Make sure you are subscribed so you don't miss our next deep dive. To be honest, putting this video together was a bit of a marathon. Digging through the field reports for 2 different systems and trying to separate the marketing hype from the reality took a lot of late nights. We actually had this draft sitting in the pipeline for a while, but when that news broke about Sweden sending 26 more archers, it gave us that final kick. We realized, okay, this isn't just history anymore. This is unfolding right now, and we knew we had to get this out to you immediately. So I'm really curious, how does this new deep dive format land with you? Is this detailed, comparative style something you want to see more of? And seriously, tell me what we should tackle next. Tanks, drones, electronic warfare? The comments section is open and I read everything. Thanks for sticking around, guys. See you in the next one. Greetings, viewers of military television. Today we're going to show you the Polish 155mm self-propelled artillery system, KRAB. We're standing inside this impressive hangar of the 26th Separate Artillery Brigade. Let's take a look at what this machine really is, how it destroys the enemy, and what it can actually do in combat. Gun commander of this Polish SPG, what can you tell us?
I've got something to compare it with. I previously worked on the PZH 2000. The tasks assigned to the KRAB, it performs them flawlessly. Compared to the PZH 2000, the main characteristic that matters most to me is accuracy. That's my personal opinion. It feels more precise, more surgical, like a sniper rifle among artillery systems. It hits the target very cleanly, very consistently.
Since we're already comparing it to the PZH 2000, the KRAB is a mix-and-match design. It has a British AS-90 turret, a Polish-made barrel, a South Korean K9 Thunder chassis, and even a German engine from the PZH 2000. Basically a real hybrid. The Poles took the best components available on the market at the time and molded them into their own KRAB. And again, compared to the PZH 2000, I haven't personally been inside one yet, but I know it's heavily automated. Here, I can see there's much less automation.
Yes, the PZH 2000 is extremely automated, with a lot of electronic modules. In the reality of how we conduct fire missions, it simply couldn't physically handle it. The system's overheated, there were moments when even soldering on circuit boards started to flow. That made things harder. But on the other hand, it could operate in fully automatic mode, semi-automatic mode, and even manual mode. In manual mode, the rate of fire drops a bit, of course. But no matter what, it still completed the mission, every time.
The PZH 2000 can perform what's called a firestorm, quickly firing 5 rounds in rapid succession. Can this one do the same?
The KRAB 3 can do it without any problem.
3 rounds with different trajectories?
Yes, exactly. 3 shells arrive on the same target at the exact same moment.
What's the maximum number of rounds you fired in a single day?
Personally, with the PZH 2000, my crew and I fired 240 shells in one day. With the KRAB personally, with my crew, 140 shells in a day.
But you said the electronic blocks were overheating, and still it could push 240?
According to the technical specs, yes, it was possible. But the reality of the war was different. There was a massive assault going on, and we had to keep firing.
And can the KRAB do 240 in a day?
I don't know. Personally, I haven't tested it.
But can the crew physically load and fire 240?
If we manage to do it on the PZH 2000, we'll do it here too. The main thing is whether the machine itself can withstand it. The crew will handle it.
Comparing it again, since the turret is from the AS-90, the AS-90 has a shorter barrel. Here the barrel is longer. But like the AS-90 turret, there's also a second engine, basically a generator, a small auxiliary engine that allows.
The Poles joked a bit, bragged about it, calling it a Lamborghini engine. Yes, the PZH 2000 also had a generator built directly into the vehicle, but we barely used it. With the KRAB, we use it constantly, every single day. When the main engine is shut down, the generator recharges the batteries because the fire control systems draw a lot of power. You can recharge calmly with much lower fuel consumption. All the lighting, everything in the gun, it can run either off the generator or off the main engine, just not both at the same time. They have to work one after the other.
How many batteries total are there?
In the turret, there are 4 main batteries and 2 auxiliary ones. For the driver, is it 6 or 8? 6, right? 8. 8.
So that makes 12 batteries in total.
The driver's batteries are dedicated to the chassis and his systems. The ones in the turret are for the main systems, the artillery side of the gun.
And let's talk about ammunition while we're here in the turret.
Support the channel with a like and subscribe.
First thing I notice, there's a lot of space. I know that 5 crew members can sleep right here on the floor. There's even a mat. But the main thing I see is some kind of semi-automatic loading system. How much ammo does it actually carry?
The SPG's onboard ammo load is 40 complete rounds. There's semi-automatic loading, what we call a magazine. First, the shells are loaded into that magazine, and during firing, they're rammed into the barrel from there. There's also manual loading. For that, rounds are placed on the side rack and fed by hand. This mechanism is rotated by a handle, released, placed onto the tray, and from the tray it's sent into the chamber.
So the crew doesn't have to carry a shell 10 meters. They just grab it from here?
The main thing is to load it into the system first.
And from below? That's also possible?
Yes, they're fed directly. The key point is that once the gun is laid on target and the barrel is elevated, this element isn't in the way. It stays down below. It's convenient. The commander can also perform the gunner's function. For example, from this position, everything is reachable and you can calmly lay the gun. When automatic laying is used, you just input the azimuth into the sight and press one button. It lays itself automatically. Hold it until it zeroes out, and that's it.
So in principle, the gun commander mainly needs the driver, and that he's fully capable.
And someone to load. If the driver knows how, then the driver alone can be enough. Technically, in an emergency, it can work like that. Of course, not for long.
We talked about firing 140 rounds in a day. How is it with fume extraction? Does smoke get inside?
We turn it on. We have forced ventilation. There's a unit in the rear, basically an air conditioner or powerful fan. The ventilation system pushes air in here under proper pressure. Each crew member has their own individual air intake port. This compensates for the gases after firing. The propellant gases and smoke left in the barrel are pushed outside through the barrel. They very rarely get inside. Sometimes a little, but nothing critical.
As I understand it, since the turret comes from the British AS-90, and the AS-90 had its own so-called multi-cooker, you kept that feature too.
The kettle? Yeah, it's there. It's located near the heating system. There are 2 heating systems here because we used to live right inside the vehicle.
So you were making tea right inside?
We made tea. There was boiling water all the time. You could even cook something if needed.
And like on the British Challenger, is there a toilet in here too?
No, no toilet, just field conditions.
So they kept the multi-cooker, but didn't give you a toilet?
Well, at least there's something. That's already good.
During firing, I was standing here during a shot. I expected it to be like everyone covering their ears, mouths open, screaming, "Ah, Mom!" But in reality, it's actually very quiet inside.
Very quiet, yes. There are crew helmets with built-in active hearing protection, but we practically don't use them. There's just no need. The sound of the engine itself masks the shot, depending on which propellant charge you're using. On a full charge, it's a bit louder, but nothing critical.
On a full charge, with your ammo, how many types are there, 5 or so?
I've written down more than 30 different ammunition designations.
All right then. What's the optimal distance on a full charge? How far can the KRAB accurately hit?
Hit? That depends on many factors. It depends on target observation, on weather conditions, on the quality of the propellant charges, because they come from different countries, with different quality and different weights. This is all about experience. The more experience you have, the better. Every batch, same charge, same type, same country, but a different production batch can still shift muzzle velocity slightly. All of that comes with experience. When these factors are more or less known, and you've already worked with them, the probability of hitting at long range increases significantly. Personally, when we were working with full situational awareness, I could see the target directly on the commander's computer. 31 kilometers. That's about 19.3 miles. That's the maximum distance I personally fired at, where I could visually confirm the target data. Right now, we work from a command post, so we don't have that level of direct information anymore. But for those who are curious, that's how it was.
So, to put it simply, you didn't fire at 40 kilometers?
With rocket-assisted projectiles, yes, we did. With Excalibur rounds especially. Personally, our guns fired more than 21 to 22 Excaliburs in a single day.
At what range?
There were two variants, but we worked out to around 38 to 40 kilometers, depending on where the target was. Those were known target coordinates. The Excalibur is programmed in its own way, and we knew exactly where it was going.
And they say that when the programmer is turned on, a lot of people don't like it.
Yes, a lot of people really don't like it. It lights up very noticeably, let's put it that way.
So bottom line, compared to the PZH-2000, how does this machine stack up?
Well, I work on this machine much more now than I ever did on the PZH-2000. What makes it good, and I'll repeat myself, in my opinion, compared to the PZH-2000, you can quickly blanket an area, close off a grid square very tightly and very fast. Shells are still in the air and you're already moving. With the KRAB, it's just slightly slower, but it's more accurate. It follows spotting adjustments very precisely, listens to corrections well, and you can accomplish the same mission with less ammunition expenditure. It's a very good system, and extremely easy to train personnel on. Personally, I've already trained 2 gun commanders on it. They've gone on to train gunners and other crew positions. It's so simple that a person climbs in and immediately starts working. I literally show them what to do while we're already firing. Theoretically, you say 2 words, and the guys already know how to operate it.
You can't do that with the PZH-2000?
No, it's very complicated. Everything is heavily computerized. Computers for every process. For every loader, you have to input the shell type, the charge. And first of all, the language isn't ours. The KRAB is different. You get in, you immediately like it, and you work. Everything responds. And if something doesn't respond or automation doesn't work, you just switch it aside, do the mission manually, then fix it and keep firing. It's very fast to repair in the field.
That's solid. Respect. Thanks for the work.
Actually, according to the manual, lighting a fire under a tank is strictly forbidden. Not because of the smoke getting in your eyes, but because the commander's balls will boil and then... While in these frames, a driver mechanic is warming up a T-72's engine, here a Ukrainian driver is warming up a BMP's.
Basically, the tracks are frozen solid. We can't break them loose, so we're heating them up.
How do harsh weather conditions affect the operation of American M777 howitzers, Leopard and Abrams tanks, Marder and Spartan IFVs, Archer and Caesar SPAs compared to Soviet counterparts? Not on paper, but in the heat of battle. How much does the frost change battle tactics? And how does winter impact not just the machines, but the men inside? You're about to find out. Let's start with the tracks.
This is an FV-103 Spartan. You can't see it from the outside, but there's a standard problem here for armored vehicles. The mud turns into ice, blocking the mechanical elements of the transmission, brakes, and controls.
As you can see, Soviet and Western machines share the same problem, except for the fact that on modern IFVs, you often can't heat the tracks with fire. For instance, on Western machines like the Bradley, Marder, or CV-90, they use rubber metal joints in their tracks. It's the standard NATO solution because it cuts down on noise, vibration, and wear on the running gear. The same applies to Western tanks. Leopard 1 and 2, Abrams. That's exactly why Ukrainians don't light fires under Western tanks and IFVs. So, what's the move then? The first rule for any tanker: clean the mud and wet snow off the tracks and chassis the second you stop moving, before it all freezes solid. Just picture that process for a second, because you aren't finding any heated hangers on the front lines. It's back-breaking work. Another issue: the rubber pads. They give you great handling on hard, dry ground, but they slide like crazy on ice and mud, because rubber on ice makes a multi-ton machine practically uncontrollable.
Sometimes we can't even roll out for a mission because the tracks are just slipping.
In the comments on this video about the Leopard 1, veteran tankers correctly pointed out that those rubber pads need to be swapped for metal grousers for better grip. Thanks for watching and commenting on our videos. The thing is, sometimes the climate in eastern Ukraine, where the main fighting is happening, is comparable to the climate of North Dakota in the US. But just a few hours after a hard frost, it can start raining and everything around you turns into a thick mush. And while you can quickly throw chains on wheels and take them off, tracked vehicle crews simply don't have the luxury of wasting 1 or 2 hours changing shoes in combat conditions. So, what's the way out?
This log right here, it's a very important piece of kit. If a tank gets stuck or caught in a deep rut, you throw the log under the tracks and the tank crawls right out.
You're looking at that exact same log on a Marder right now. Now you know why it's there. Mystery solved. So we're waiting for your like. Hit it right now. And make sure to subscribe to this channel so you don't miss videos about equipment, not from some proving ground, but in real combat conditions. And right now, you're going to see how tank and IFV's engines handle the brutal cold. So, while this tanker is watching our new video, his T-72's engine has to warm up. Is it really possible to do that using an open flame? In reality, the tanker is heating the oil and antifreeze, because at temperatures below 5 degrees Celsius, a standard start is forbidden, since the thickened oil won't provide proper lubrication for the engine. To start the engine during freezes, modern Ukrainian versions of the T-72 are equipped with auxiliary power units, APUs, which power the electronics and pre-warm the tank's systems without firing up the main engine. But on this tank, it looks like the auxiliary engine is broken. So the tanker is using a World War II method from back when crews warmed up their tanks with firewood. German tanks also have a built-in preheater that warms the engine, oil, and fuel system before startup. After a few minutes of it running, the engine cranks right over. The American Abrams doesn't have a conventional engine. It's got a Honeywell AGT 1500 gas turbine, almost like what you'd find in a helicopter. The turbine couldn't care less whether it's freezing or not. It doesn't even use antifreeze. The main things are having working batteries, enough fuel, and clean air. However, before a fight, the Abrams requires a so-called warm-up routine. The crew spins the turret to warm up the hydraulic fluid in the systems, and only after that is the tank ready for the mission. And just how comfortable is the temperature inside the tank? Oh, now that's an interesting point. German Leopard tanks, regardless of generation, pack an autonomous diesel heater that blows warm air into the interior space. And the Leopard 2, thanks to its composite armor, which acts as thermal insulation, is the gold standard for comfort, because practically in any winter conditions, it keeps room temperature inside the machine. The American Abrams is also equipped with an autonomous personnel heater that runs on fuel and pumps warm air into the fighting compartment and the driver's station. And the exhaust temp from that gas turbine engine is so high you can literally warm yourself standing next to the tank. With T-Series tanks, things are way more complicated. Here's its heater.
Basically, it's a standard radiator that the engine antifreeze circulates through. And this is a fan that blows the air. As you can guess, a heater like this can't provide any real warmth.
Meaning, tankers first have to wait until the engine temp hits 100 to 120 degrees Celsius. But even after painful minutes of shivering from the cold, the crew doesn't get any heat. So how do the tankers stay warm? In the T-Series, clothing is half the survival system. Tankers use multi-layered winter uniforms, thermal underwear, and chemical heat packs. Their own breath also adds a couple of degrees of warmth. But here's the problem. All that breathing in a cramped space creates high humidity and condensation, so you have to crack the hatch. On top of that, you have to open the hatch even during combat ops, because due to the flaws in the forced ventilation system, gunpowder fumes build up in the fighting compartment. In T-64s and T-72s, after a shot, the breech opens to eject the casing stub. At that moment, a small amount of gas that didn't make it out through the bore evacuator inevitably leaks into the fighting compartment. This leads to a spike in carbon monoxide levels, which can cause dizziness, nausea, and rapid crew fatigue. You gotta agree, it's better to open the hatch than to black out. That's the hard lot of tankers fighting in Soviet-style tanks. However,
no complaints here. It's the best job in the world.
makes sense because there are fighters who have it even harder. The gunners working in towed artillery crews. The Ukrainian winner has become a real test for the American M777s. They call her the fragile howitzer. Did you know that freezing temps cut down your firing range? Cold air is denser than warm air. That creates more aerodynamic drag on the shell, causing it to bleed speed faster and drop sooner. Let's see if the boys can handle it. Because of the freeze, the powder burns slower. That lowers the gas pressure in the chamber, meaning the shell gets less muzzle velocity. The total loss in range can be up to 1 kilometer. So, lubricants thicken up in the cold, which can slow down the movement of the firing pin or the breech, further messing with the stability of the shot. And in extreme frost, the primer might not strike, or the powder won't ignite properly, leading to hang fires or misfires. Job done. The commander accounted for every nuance tied to the cold. But with the M777s, it's not always smooth sailing.
In winter, you get both rain and freezing temps. Ice cakes onto the gun, so we use a Webasto to warm her up before we use her.
Because of the frost, the metal parts of the M777s become more brittle, and the lubricants thicken up, which demands special maintenance and preheating before use. By the way, there's a separate video on this channel about operating the M777s in Ukraine, where the fighters speak openly about how the American howitzer performs in different conditions. But how do the Soviet-style howitzers, which are still plentiful on the front, handle their mission in winter?
It's hard to call a gun developed in the middle of the 20th century a modern weapon, but she gets the job done.
This is the D-30, an old, heavy, towed 122mm howitzer with absolutely no frills. Like a three-legged stool. Simple, but rock steady. There's no automation here, no little engine to move it around. Everything is done by hand. However, this Soviet gun is no less fragile than the American Beauty.
There are plenty of problems. You absolutely have to clean her, the barrel, the breech, the chamber. Often you have to do it all on the fly.
On top of that, a certain nuance popped up that might actually surprise you.
We have a few D-30s in our brigade, and over 2 years we've worked on all of them. We've learned them all inside out. Turns out every single gun works a little differently. You get what I mean?
Honestly? No. If you've heard that every gun of the same modification and same manufacturer shoots differently, then drop a comment about your experience under this video, just like the tankers do. However, M777 and D-30 artillerymen share one common problem. During freezing temps, these guns become way less maneuverable. A towed howitzer is extremely hard to tow, and when the fighters move into a new position, the gun absolutely has to be partially dug in to hide it. And digging into frozen ground, that is a nightmare. Do you think it's easier to fight in an SPA? Here's what we managed to find out. When the Archer SPAs first showed up on the front, their crews were considered the lucky ones, because these guys always return to base after work and sleep in warm beds.
In just 30 seconds we set up, fire, and 30 seconds later we pack up and move out again.
The wheeled chassis and articulated frame give the Archer incredible maneuverability and high movement speed. And the climate control system creates office-like conditions for the crew, because all the work controlling the gun and firing happens from inside the armored cab. However, 2 years have passed, and the advantages of this advanced system have turned into weak points. The first warning signs appeared back in the summer.
Here's our Archer, totally frozen up. We're in the middle of this damn field waiting for an enemy Lancet. Here are the anti-aircraft guys. One of my buddies is scanning for the Lancet in the air. The other, decided to take a leak because he says we're all screwed anyway. That's how it is.
Likely due to the heat, the hydraulic system lost the pressure needed to quickly switch to the stowed position. If the sensors detect that the gun hasn't returned to the 0 position, the safety system blocks the folding mechanism. But if the oil boils in the summer, in the winter it thickens up, so the pressure sensors block the system then too. Another vulnerable point is the articulated frame. It's a very complex mechanical assembly that is sensitive to mud and ice, because all the hydraulic system lines are located on the outside. If they get damaged, the vehicle effectively loses mobility. And finally, the basically civilian Volvo engine. It's too fragile for war because it requires very high-quality fuel and maintenance. There is info that after 2 years of operation, out of the 8 Archer SPAs Ukraine received, only 2 to 3 remain in service. The others need maintenance that can only be done in Sweden. Maybe that's why the new Archer SPAs will get a different chassis. And what about the French Caesar?
We tore a brake hose here. Because of that, the vehicle stopped and isn't moving anymore. When there's mud and frost, this is gonna happen almost every day.
The Caesar SPA also uses a civilian chassis. And while fixing it doesn't require a shaman and a laptop, in winter you really want something more rugged and reliable because Lancets are constantly circling overhead. This is the self-propelled artillery system 2S1 Gvozdika. Simple as a hammer, it reminds you of a big iron turtle. Inside, it's pure luxury, a roof over your head and at least some protection. In winter, it's warmer here than next to a gun out in the open air. And if freezing rain is falling, you don't have to hide under a poncho. Unlike towed guns, the Gvozdika arrives at the position on its own, deploys quickly, fires, and gets the hell out just as fast. That means the main thing, more chances to survive. She even knows how to swim.
Well, no. This Gvozdika doesn't swim anymore because she's full of shrapnel holes everywhere.
Because of the drone hunting, sometimes it's safer for the crew to stay put and hide near the firing position. Then this cramped space becomes home for the crew of 4 people for 10 days, or even more.
I'm the gunner, so I sleep right here. The loader sleeps over there, and the commander, he basically has almost a private room back there.
Of course, these aren't all the stories of the Winter War. From this video here, you can learn how the infantry survives in trenches and dugouts during the freezes, snowfalls, and thaws that follow one another in quick succession. Let's be honest with each other for a moment. If you look at the modern battlefield, a place dominated by modern missiles, active protection systems, and tanks that cost as much as a small island, and then you look at the FV-103 Spartan, you have to ask a difficult question. Why are we looking at this? It is a 50-year-old aluminum box. It was designed when disco was topping the charts, and the Cold War was freezing over. By all modern military standards, it is obsolete. The British Army, the very people who built it, sent it to the retirement home nearly 15 years ago. When it first arrived in Ukraine in July 2022, the serious military analysts didn't applaud. They shrugged. They looked at its thin armor, its cramped interior, and its weak machine gun, and they labeled it junkyard tech, a desperate band-aid for a desperate army. But here is the mystery that defies the spreadsheets and the war college doctrines. 3.5 years into the most brutal conventional war of the 21st century, the number of these obsolete vehicles on the front line hasn't vanished. It has exploded, from a handful of donations to a fleet of hundreds. Even more baffling? While modern heavy multi-million-dollar tanks are burning in the mud of the Donbass, this little aluminum relic has an 82.5% survival rate. How does a vehicle that was essentially thrown away by NATO become a frontline monster in Ukraine? Is it possible that our obsession with high-tech, high-cost armor has blinded us to the brutal reality of what actually works in a war of attrition? Today, we are going to dive deep into the metal soul of the Spartan. We are going to strip away the paint and the propaganda to analyze why a piece of Cold War history is outperforming the cutting edge. We will look at the terrifying trade-offs its crews make every single day, trading armor for speed and comfort for survival. Is the Spartan a hero? Or is it a death trap that got lucky? The answer is far more complicated and far more uncomfortable than you might think. By the way, this video marks the launch of a completely new format on our channel, a pilot episode for our deep dive series. We are moving beyond simple spec sheets to rigorously analyze how specific Western systems have actually performed after 4 grueling years of combat in Ukraine. And your feedback on this approach is crucial. Let us know in the comments. To understand the miracle of the Spartan survival, we first have to understand what it was supposed to be, and more importantly, what it was never meant to be. Go back to the 1970s. The British engineers who drafted the blueprints for the Combat Vehicle Reconnaissance Tracked Family, the CVRT, were operating under a specific philosophy. They didn't want a brawler. They wanted a ghost. The design brief was simple. Create a vehicle fast enough to keep up with the tanks, but light enough to be air transportable. They made a radical choice. Instead of heavy steel, they constructed the hull from a welded aluminum alloy. The thickest part of its armor, the front plate, is only 60 millimeters deep. In the brutal calculus of ballistics, that means it stops a 14.5 millimeter round, a heavy machine gun bullet, but only if it's fired from 200 meters away. Anything closer, anything bigger, it punches right through. This was not a machine designed to storm trenches. It was a support worker. In the early 1980s, its job was to hide in the bushes, carrying teams equipped with Javelin and Starburst manpads, shoulder-fired anti-aircraft missiles. It was a glorified delivery truck for specialists. By 2009, the British military looked at the Spartan and decided its time was up. The world had changed. Make sure you are subscribed and have notifications turned on so you don't miss our next video. In the dusty roads of Iraq and Afghanistan, where the threat was an IED buried in the sand, a flat-bottomed aluminum hull was a liability. The British replaced it with the Panther, a wheeled, comfortable modern vehicle based on an Italian design. The Spartan was stripped of its duties and sent to the scrapyard. So, when the full-scale invasion of Ukraine began, and the UK dusted off 35 of these retirees to send east, the expectations were incredibly low. Against the Russian war machine, the Spartan looked paltry, inadequate, a token gesture. But war has a funny way of humiliating the experts. The analysts missed something crucial. They were judging the Spartan by the rules of NATO doctrine, mechanized warfare where infantry fighting vehicles advance side by side with tanks, suppressing the enemy with autocannons. But the Ukrainians realized very quickly that if they used the Spartan like a Bradley or a Warrior, they would die. The armor simply couldn't take it. So, they didn't try to force the Spartan to be a tank. They looked at its specs, the very things that looked like weaknesses, and flipped the script. They turned this support vehicle into the world's most dangerous taxi. Listen to the words of a Ukrainian soldier describing their new doctrine. Our job is to move in unnoticed, complete the task unnoticed, drop off the assault team unnoticed, get in, get our guys out. That's our main mission. Notice the repetition of the word unnoticed. This is the key. In a war where the sky is filled with thousands of watching eyes, drones that can spot a mouse in a field, being big and heavy is a death sentence. The Spartan is tiny. It is under 17 feet long and less than 9 feet tall. You can tuck it under a tree, throw a net over it, and it vanishes. Compare that to a BMP-3 or a massive American Bradley. The Spartan is a ghost. The strategy is terrifyingly simple but effective. The vehicle waits, engine off, hidden in a tree line miles from the contact line. This minimizes its thermal signature. It's cold, dark, and silent. Ahead, FPV drones scout the route, looking for the gaps in the Russian vision. When the call comes, the driver hits the ignition on the 4.2-liter Jaguar engine. This is a petrol engine, capable of pushing this aluminum box to 60 miles per hour. That is a mile a minute. They burst from cover. They aren't marching, they are sprinting. The goal is to slash the reaction time of the enemy. By the time a Russian drone operator spots the movement, relays the coordinates to the artillery battery, and the gunners lay the weapon, the Spartan is already gone. It has dropped its stormtroopers right on the trench line and is peeling away. This is the armored taxi concept. It is not about fighting from the vehicle. It is about delivering the fight to the enemy and surviving the commute. There is another factor here, one that you cannot understand until you have stood in a field in the Donbass in November. The soil, the infamous black earth. When it rains, or when the spring thaw hits, This ground turns into a substance that defies physics. It swallows boots, it swallows trucks, and it swallows tanks. We have seen the footage. 60-ton German Leopard 2 tanks, miracles of engineering, churning helplessly in the mud, sinking to their axles. A stuck tank is a dead tank. This is where the Spartan's weakness, its lightweight, becomes its superpower. The Spartan weighs just over 10 tons. That weight is distributed across 2 tracks. If you do the math, the ground pressure it exerts is roughly 0.4 kilograms per square centimeter. To put that in perspective, a human soldier jumping off the back of a Spartan might get their boots stuck in the mud, while the vehicle itself glides over the top. A T-72 tank exerts more than double that pressure. In the soggy hell of the Eastern Front, mobility is not just a feature. It is the primary layer of armor. If you can move where the enemy thinks movement is impossible, you have the tactical advantage. The tracks, which the British saw as a maintenance headache,